Consider the graph of y equals sine x shown below. Why can this function not have an inverse when defined on its natural domain? There's that term natural domain again. Natural domain is the largest set of values that you can input into a function. So with sine, there's no problem. Anything from negative infinity to infinity can be substituted into it. And that's why we've got these arrows indicating the continuing trend in the graph. For something like a square root, you know that you can only have positive values or 0 underneath the square root. And if you have something that's like 1 over x, there's specific values, like you can't have x equals 0. If that was 1 over x plus 2, you couldn't have x equal to negative 2 because you can't have a 0 in the denominator. So for this, the natural domain is all x values. The answer here, though, is it's just not 1 to 1. Or you could equivalently say that it's many to 1. So suggest a domain restriction so that it can have an inverse. Well, we saw one such before, which goes from negative pi by 2 to pi by 2. So if I do that, I've then got a 1-to-1 function. And obviously you could do it anywhere on the graph. So we could have actually taken this bit over here if we wanted to. But this is the one that your calculator actually uses. If you try doing inverse sine of something on your calculator, you'll find you always get a return between negative pi by 2 and pi by 2, or in degrees negative 90 and 90. And that's because it's this restriction that's actually used in the formal definition. So what we're going to do is we're going to say x is a real, x is more than or equal to negative pi by 2, less than or equal to pi by 2. Sometimes people don't state the x is a real bit, sometimes that's taken as read.